Every single year, thousands of students literally drop an entire grade boundary in Cambridge IGCSE Physics 0625. And the crazy part? It is not because they don't understand the underlying physics. It's because they fall straight into the examiner's trap on motion graphs. Well, today in this explainer, we are completely dismantling that trap.
Right, let's just jump straight into the deep end with a before and after shock. Look at this painfully flawed 2 out of 10 student answer. It says the line goes up, so it's getting faster. Ouch! Now compare that to a top band 9 out of 10 answer. The constant positive gradient indicates constant acceleration. It's the exact same graph, but it results in entirely different marks. If you want to secure those grade boundaries and actually protect your score, we've got to shift your mindset to that top band approach right now.
And that perfectly illustrates exactly where we are operating today. We're looking directly at Cambridge Syllabus Section 2, specifically Units 2.1 through 2.5, on forces in motion. So we're talking about speed, velocity, acceleration, and most importantly, the complex motion graphs that test all of those concepts. We're grounding our entire strategy in the exact parameters that the examiners are using to test you.
So, here is the absolute crucial point. We have to understand why ordinary everyday revision fails. Look, you can memorize the entire textbook, but if you sit down at that exam paper and make these common errors, your marks are just going to vanish. I'm talking about things like missing units, rounding your numbers way too early in a multi-step calculation, graph axis errors where you just misread the scale completely, using the wrong variables, offering really weak practical improvements, or writing conclusions that just aren't supported by the data you literally just calculated. These are the fatal, real-world traps that consistently rob students of top grades.
To completely bypass those traps, you need a highly structured system, and that is what I call the top band answer framework. This right here is your first big, quick win. It is a mandatory 4-step process for constructing a perfect, totally examiner-proof answer. Step 1 is concept. Step 2 is evidence or data. Step 3 is scientific reasoning, and Step 4 is examiner wording.
Now, in just a moment, I'm going to show you the exact examiner clue that changes your answer completely. Seriously, it's a real game changer. But first, you absolutely need the framework that actually makes that clue obvious. Because if you don't grasp how these 4 steps connect, that clue just won't save you. So stick with me and pay close attention here.
Let's break this whole thing down. Step 1 is concept. When you see a motion graph question, your very first action must be to state the key definition, law, model, or equation, and you have to use precise physics terminology. Please don't just start blindly punching numbers into your calculator. State the physics concept first. Why? Because that secures your initial method mark immediately. It signals to the examiner that you know exactly which physical law governs the graph sitting right there on the page. Next up is Step 2, evidence and data. You need to safely extract your numerical evidence directly from the motion graph. You've got to pay hyper attention to the correct graph scales and units and clearly show your substituted values in your working out. This right here is where so many students fall into those graph axis traps or end up rounding off their numbers way too early. Pull the data accurately and write it down clearly so the examiner can see exactly what you're doing. Then we move to Step 3, scientific reasoning. This is where you actually connect the dots. You have to logically link that extracted data back to your initial concept. For example, is the gradient constant? Okay, well, does that prove constant acceleration? You need to explain exactly why a specific graph gradient or maybe an apparatus setup physically proves your conclusion. Simply stating the conclusion isn't enough. You've got to write out the reasoning that gets you there. Finally, we hit Step 4, examiner wording. Honestly, this is the ultimate hurdle. Having the right data and the right reasoning means absolutely nothing if you don't use the exact terminology the examiner's mark scheme is specifically demanding. You must fulfill the exam requirements with safe, highly accurate phrasing. If a question tells you to evaluate, well, simply describing a trend isn't going to cut it. You have to use the precise vocabulary they are hunting for. Okay, let's actually put this framework to the test with a quick interactive challenge. I want you to spot the common error here. Imagine a student writes this down. The car's acceleration is 5. What is the fatal mistake in this painfully common calculation? I genuinely want you to pause for a second right now and mentally predict the flaw. Got it?
Boom, here comes the examiner's red pen. Missing units. The correct answer absolutely must be stated as 5 meters per second squared. Writing a numerical answer without its correct unit or worse with a totally incorrect unit is severely penalized in Cambridge 0625. Just make it a rule for yourself. Never, ever leave a naked number on your exam paper. It's just a guaranteed way to bleed marks for no reason.
All right, let's escalate the stakes a bit with a harder, practical investigation example. Say you have a flawed answer that just suggests use a better stopwatch. Look, that is vague, it's totally subjective, and frankly, it earns 0 marks. What does the improved, top-band answer look like? It says, use light gates to eliminate human reaction time. See the difference? That brilliantly proves to the examiner that you truly understand practical accuracy and scientific experimental design.
Before we wrap this explainer up, you need to firmly lock this strategy into your brain. Here is a rapid-fire, final answer checklist that you should run through before you consider a question finished. Ask yourself, are my units present? Are my significant figures actually correct? Is the graph scale accurate? Did I factor in reasonable uncertainty? And were safety or practical improvements considered? Just quickly run this checklist in your head, and I promise you, you're going to eliminate those silly mistakes that ruin a perfectly good physics paper. So you now have the ultimate 4-step framework to build a top-band answer. But here's the massive, unresolved problem we're left with. This whole framework is completely useless if you misinterpret the exam question in the very first place. Do you actually know how the specific command words, like evaluate versus describe, decide your final mark band? Well, in our next explainer, we are unlocking the command word secret that dictates your final grade. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click on that next explainer right now to master the command words, because you really don't want to skip this step. I'll see you over there.